the snake descends more than 9,000 feet and traverses 1,000 miles of mountains and high desert before joining the Columbia River. More than 65 million years ago, the continental divide began rising and diverting water west toward the Pacific Ocean. Thus began the Snake River drainage system. About 15 million years ago, lava began pouring up from within the earth in eastern Washington, eventually creating the Columbia Basin Plateau, which is nearly 5,000 feet thick. As the plateau continued rising, the snake continued carving through the lava, creating the basalt cliffs you see today along the lower Snake. Following the plateau buildup, a series of ice ages occurred and large continental ice sheets covered the North American continent. While these ice sheets were far to the north, they still had a significant impact on the evolution of the lower Snake. For millions of years, continental ice sheets have advanced and retreated with the changes in climate. With each retreat, the melting ice water released large amounts of gravel and soil to flow over the Columbia Basin Plateau. About 12,000 years ago, in what is now Montana and Idaho, large ice dams backed up enormous amounts of meltwater, forming prehistoric Lake Missoula, larger than Lakes Ontario and Superior combined. Pressure from the large volume of water eventually resulted in a massive failure of the ice dams, which released enormous amounts of floodwater roaring across the entire Columbia Basin Plateau. These massive floodwaters scoured the land and formed the impressive Palouse Falls, as well as other steep-walled canyons in the area. When these floodwaters reached the narrow Wallula Gap, a gigantic temporary lake named Lake Lewis was formed. Wind-driven waves on this enormous lake created unique terraces that are still visible today. This cycle of ice dam buildup and failure happened many times during the last retreat of the ice sheet, creating the scores of rugged cliffs and canyons you see today in the area.